In this video we'll focus on how packet error rate varies with distance while using the Thorp Pathloss model in underwater acoustic networks. Let's start. Click on the New Simulation tab, then click on Underwater Acoustic Network Library, which is present on NetSim home screen. This will take you to the simulation environment, which is a grid view, where you can create the network scenario. In this example, let's set the grid size for the environment to 50 km cross 50 km. For this, you can change grid size under the grid properties. Set width to 50,000 meters and length to 50,000 meters. Now we can design our network. For this example, we choose the simplest network with 2 nodes. Firstly, click on Ad hoc link icon from the toolbar and drop on the grid area by simply clicking on the grid. Now click on the underwater device icon present in the toolbar. Bring the cursor to the grid area and drop 2 devices. They are connected automatically using an ad hoc link. For this example, we set device positions at 17 km from each other. For this you have to click on Underwater Device 1. Under the Properties tab, you can click on the Position option and set the X, Y, and Z coordinates for the devices. Modify the X coordinate to 10,000, Y coordinate to 20,000 and Z coordinate to -100, which is the depth of the device. Similarly, you can set the X, Y, and Z coordinates for Underwater Device 2. Modify the X coordinate to 27,000, Y coordinate to 20,000 and Z coordinate to -100. Now go to the Interface Physical Layer property. Set source level to 190.8 dB per micropascal and frequency band to 20 kHz in both the devices. Now click on the ad hoc link. In the medium property, set channel characteristics to path loss. Set the path loss model to Thorp with spread coefficient value as 2. Now let us configure data traffic between Underwater Device 1 and Underwater Device 2. For this, click on Set Traffic option from the menu bar. Click on the CBR icon from Unicast Applications to configure a constant bit rate traffic. Now click Underwater Device 1 and then click Underwater Device 2. The CBR traffic is configured. Now click on Application Properties in the right panel. Go to the Packet Size option. Packet size is set to 14 bytes, keeping in mind that the acoustic networks use small packet size for packet transfer. Set packet inter-arrival time to 1 second or 1 million microseconds. The generation rate is calculated to 112 bits per second automatically. Now click on Configure Reports tab, click on Logs icon. Enable the Acoustic Measurements log from the Network Logs. Click on the Run icon from the Quick Access bar and run the simulation for 1000 seconds. Once the simulation is completed, we get the results dashboard. From the Application Metrics table, we can see that packets generated is 1000. Packets received is 158. Throughput is around 18 bits per second due to path loss in the medium, and delay is around 415 seconds. The Acoustic Measurements log can be used to understand the effects of the acoustic propagation model and the impact of varying channel conditions. Now click on the Acoustic Measurements log from the Results dashboard. Wait for the Excel sheet to be loaded and formatted. We can see that the distance is 17 kilometers, which the distance between transmitter and receiver set in the GUI. Transmitted power is 190.8 dB per micropascal, which is the source level set in GUI for the underwater devices. Path loss, or the total transmission loss, is around 154.88 dB per micropascal, which is calculated using input parameters such as frequency band and spread coefficient from the Thorp Pathloss Model. Total noise in the medium is around 23.87 dB per micropascal, which is calculated using input parameters such as shipping factor, surface wind speed and frequency band. SNR is around 12.04 dB and is calculated using passive sonar equations. The received power of underwater device 2 is around 35.91 dB per micropascal. The bit error rate is around 0.000032, which is dependent on the SNR value and MCS set by the user. We run the scenario for varying distances from 15 to 18 kilometers and plot the PER versus packet error rate is calculated using the formula number of packets errored divided by number of packets transmitted, which can be seen in link metrics of results dashboard. We run the scenario by varying distances from 15 to 18 kilometers and plot the PER versus distance graph for different source level values. We can see that packet error rate increases sharply between 15 to 18 kilometers. Some users are interested in running custom propagation models. The source codes are open where users can write their own codes. The step-by-step procedure is available in the knowledge base article. The link to the article is given in the description below. Stay tuned for more videos.